I'm going to go over epsilon delta. I'm going to go over some of the derivative proof. I have cleaned this up to make it a little bit cleaner. I'll explain my process and if this is a good idea or not. I'll decide later. But um, I was cleaning up the limit section, another section. Um, Now I realize that I probably need to prove that a constant derivative is equal to zero and a constant that equals nothing, uh, which I haven't thought about, which I could probably put somewhere down. I just have to prove that, which is interesting. Yeah, which is fine. Um, can I put enter here and get away with it? Yes. I should probably put over here that I can get away with it. Okay. Just and you already know that this um, except x x expect no except I don't know how to spell apparently equals zero. And then I could just write t square root of zero real quick. And that should be good. Because t square root of zero is just one, which means it's a number. Whatever number it could be is zero. It could be zero to any real number, any normal number, natural number, trig. Anyway, so we're gonna start with the hop. I finally cleaned this up. I used to have highlights everywhere, which was really messy, and I realized that the highlights are not great. Just delete most of the Oh, yeah, it used to be like this. I'm just gonna do that. We're starting with the simple hop. I am gonna go back to certain things and prove it. For example, this thing, I probably need to prove it later. Clearly, I didn't prove it yet. Um, and then we start with the infinity idea, because infinity is really big concept in calculus. Haven't really, I mean, I have used it for like Fourier series, but it really doesn't go to infinity. It goes to like the third or fourth, fifth, sixth, something like that. Now this is where we get the janky stuff. So basically, what happened here is that the limit of x equals to zero. Well, we need to use the hop, and if I use the hop, I'm using this to prove something in e of x and ln of x. And I'm just saying, well, then it's a looping definition because to use the hop, um, we have discussed over here that the hop needs a derivative of each of them, and I'm trying to prove a derivative with this. So I have instead used a janky method to prove it. If I could prove it with epsilon delta, I would. But the problem with epsilon delta is that I tried it, it didn't work, and I used ChatGPT because I was desperate. Um, Still didn't work. It backfired because it kept on giving me shenanigans that didn't even make sense. You're supposed to get epsilon, and it just gave me this, and I was like, well, I know this is epsilon here, and I was just like, that doesn't really make any sense to me. Maybe it makes sense to someone else. But I have just resorted to using graph. And even if I was to get the epsilon delta, I would just say later on I'll prove it with epsilon delta down over there, which I'm going to talk about epsilon delta because you wasted a lot of time on it. Um, Now I finally understand it. It's very simple. I used to do the process of it, but I didn't understand it. Now I understand it. Now I can explain it really well, I think. Um, Now here's some derivative proofs that it really doesn't matter. How this book is supposed to be used because is that you're supposed to just have this. I say, well, write it down on a piece of paper and try it out. If you get stuck, look at this and keep on doing that process until you get the right answer. Um, it's not really used to doing, Anyway, I hope you use it that way. You can use it anytime, any way you want. Um, and there's another one over here. So another one that I need to use for the derivative of cosine and sine. You'll see that the hop also will work. Um, but you'll see how what's the right word? It just it just needs to have the original derivative. So you need this and you need this to solve this. And then you can see what the problem is at that point clearly. Maybe I should explain it. No, did I explain chain rule yet? I just realized I'm not sure if I did explain chain rule yet. Oh, I did not. Huh. So that's an oversight. This, in my opinion, should be up here. Oh, but I haven't explained sine and cosine yet, so I can't do that. I see why I did that now. And then sine and cosine is over here. Okay, so I probably want to put it over here then. Del that, and we're good. Yeah, I didn't mess anything up. Okay. So yeah, I realized that that was a little bit messed up. Then I chose. Okay, we're gonna change that to sine because I haven't actually explained sine and the cosine yet. So I don't explain the cosine, sine, cosine one. So you know what I mean. So this should reflect what I already know. So I'm saying that because with chain rule you can explain the inside and out, why that works. But I put this over here and that wouldn't make any sense. So I'm just putting cosine. And then I'm putting cosine 1 over here just to prove cosine. And now you can use cosine with the same thing. Conjugate is only here because test questions always have like one conjugate questions in the calculus one. Have never used it really, but kind of a brain teaser question, I guess. And then more of these methods, but these methods can be proved actually with epsilon-delta. I just don't want to do them, but I probably will later on just because of my just want to do it. Not looking forward to that. Oh, you know that one. That's not that hard. I mean, it is hard actually. It is just power rule, but no, it's not power. It's just plug and chug. It's just plug and chug. Yeah. And then here's more of the Lahop. And then more of the Lahop. I'm gonna go to episode delta. Don't. I mean, that's what you're here for probably, and my explanation of it. Yeah, we go to over here. As you can see, I'm very tired. It's very late. It's like 12:08 a.m., which means it's pretty much my bedtime, anyways. But anyway, over here we have more of those. I'm not sure if this is ever useful, but this is for banks, I believe. Why did I not? Why is there no? Oh, oh. Well, it's the same thing. Whatever. Doesn't really matter. Okay, so we're with the imaginary over here, or epsilon delta. So epsilon delta, I figured it out. So let me just get rid of that. So this one is, oh, I did -2. It really doesn't matter. -2. So I think I chose, what did I choose for it? I chose 0, so I chose this point over here. Let me write 1, comma 0 over here. So let me look at this point over here really quick and explain it really quick. So when I have something over here, let's just say I choose a point y equal to, and then let me just visualize it like this, and let me visualize it like, what's that point? 2, 2. So let me just put it like 2, 2. Let me just do the same thing with, I mean, you don't really need to do it because you have the line over here. Instead, let me just do x equals 0, so I can actually explain that one, and put y equal -2, so I can just do it this way, so that should have worked. No, it's opposite around, that's why. Up there, and then let me put down, right? Yes, I did right. And then you do the same thing, but with the original one and 2, right? larger, right? No, it's a y over here. That's why it's not working. Okay, so as you can see over here, you have one length over here that costs two lengths over here. So I probably should have y equal 0, and then have it as 1, and then 2 over here. So you can see the green over here is 1/2 of the long side, which is either the black one over here or the red one over here. It doesn't really matter. But you can see the same illusion over here. So that's the idea of why this came about. We're choosing a point over here. And what does that mean? It's a continuous over here, continuous over here. That really doesn't really show from here, as you can say. Now, it really does show when this happens over here. And this really does make more sense, in my opinion, when we talk about this one. Why is it not loading? What happened? I don't know what happened. When we talk about alright, this one over here. So that's over here. So we talk about this point over here. Let me look at this one over here. You can see that it's a straight line upwards over here. And that could be implied to be over here. All of this positive stuff over here. Now that makes perfect sense to me. Over here can be the negative stuff over here. And then what does that really entail for me? It means that it's continuous at this point pretty much. It means that this side over here converge and this side over here converge at the same point, which entails as the limit does exist. It's kind of really weird, but that's the formal definition of a limit. And I finally understand it. And it took forever for me to understand it. But now I understand it fully. I used to do the process a long time ago, but now I understood it fully. Now I have to finish this up later. And it's kind of very, what's the right word? Needs to be fixed. It needs to be cleaned up. Yeah. I think we're done. And in that note, I learned something funny today. Not today, like a few days ago, where I was told that European countries have free schooling, but those free schooling comes at a cost of the GPA usually. What that means is that you need a good GPA, like a 3.9 unweighted, not weighted, I think, to get into that school. Which means that you're basically saying if you have a bad GPA, that you're like a 3.7, 3.5 in high school GPA. I don't think your likelihood to get in is lower. This just shows that the difference between Europe and American schools, and the same thing with Asian schools. It's way more there. It's more about the one test for like 2 days or something. I forget. Um, I think in Korea it's like that, right? Like 1 day or 2 day that there's no airplanes going around. Anyway, that shows the difference between those kind of culture and American culture. I think it's kind of fun. It's kind of hilarious, but it's not hilarious. It actually shows you a little bit of the benefits of the American education system. You keep on negativizing it, but there's some benefits to it. It's just very expensive, as everyone says it. But American education system allows for people that don't have the best GPA to get in, and that does give you a better diversity of opinion, and usually it does also showcase other perspective than just GPA. Basically, things like your activities or other stuff like programming or something, which I think is a more holistic approach. It's interesting to say the least. I didn't know that until someone told me. Um, oh yeah, this is shenanigans I was trying to do over here. uh, uh, Not really looking forward to finding out how to fix that later because I was trying to do this epsilon thing once ago, but it didn't really work out. So I'm trying to figure out because in this case you need to show that what epsilon will equal to. In this case, you have 1 divided by x, which is epsilon there. So basically, you have two epsilons over here. one epsilon on the bottom and one epsilon here. But you need to prove that no matter what the situation is, the epsilon over there can be equal one epsilon, not two epsilon. You need to somehow, and this equation is what's the right word? It's non-uniform, which non what's the right? Okay, so we're good with that section. I don't think I have ever talked about the geometry section or any other section that I have done or redone a little bit. So while you're looking at it, I can just talk about the other stuff, like, I don't know, Noah's Ark. Fun fact, I had a thought about Noah's Ark, actually. Um, Even if for it to even exist, you probably need some better technology than that. And also, I can give them the credit of doubt if there was some potency, because you need both to have some metal, I think. Anyways, yeah, I do wonder what kind of crazy world it would be before, because it was said that they flooded the world, which basically means that they had to do something crazy, because the gods haven't flooded us yet, which is kind of questionable. Anyways, I was just thinking about that because for some reason, I'm interested in that story a lot for some reason. I think it had to do with like a whole system that was just cannibalizing people. Probably that's the only thing I can think of that would be that evil. Because human, I mean, then again, there's humans that have dark thoughts, very dark thoughts. That I only know because if you watch some anime, you'll find out very fast how much of these thoughts are darkest, deep dark. That there's no justification for. I mean, I just yeah. Anyways, so they're cleaner now. I think a lot of this is clean now. I mean, there's some things I need to change, but I do use calculus to define some of the things. It's just easier that way, honestly. Um, yeah, for example, I did the donut thing. I mean, that was a let's just say not a fun one. But the easiest way to figure it out is that always remember the square root of r squared minus x squared is always a circle. So that's the most helpful thing in there, anyways. Yeah, for the trick one, it was a little bit off a little bit. I don't know. I also have. I don't think I showed this, did I? I did this one mostly due to another thing I wanted to show. Uh, yeah. Oh, this is a little bit of an awful thing. You can just figure it out over here. This is basically arctan. If you close it like this, if you do this, you can see that it's arctan. Um, I really don't want to discuss about that. I more want to discuss about this thing over here, where we have this function over here, which is basically this function. It's a little bit off over here. Um, Now we have xi as factorial, which has certificated interval, and I figured out this continuous function of this, which is n is n integers, which means you can figure out the integral of this by just taking integral of this, which means you can solve the whole thing. And now to prove that xi is a continuous function, um, here's xi as a continuous function. As you can see, that is the same as this if you figure it out. Yes, this is the same. Anyway, what was I talking about with Noah's Ark? Anyways, the system. Yeah, the only reason I figured out that probably was could be true is just because there's some certain animals that are completely insane, or mangas, that advocate for certain things. Anyways, now here's another thing I want to find interesting. So, over here I put a sketch of this, and I put it pretty much a circle, because certain things, I mean, engineers would just say it's a circle, right? I mean, at this point, it's 0.05 equals 0.05. So it's actually showable in a graph that does show a little bit tilted this way over here. But in reality, it really is just a circle. I don't have a very big faith in humanity a lot, anyways, because of that idea. Anyway, also, here's another one that's very interesting. I don't think I ever showed it off, so I'm just going to show it. And that's pretty much done with the update of my textbook. Anyway, I'm gonna actually change this. I also learned a lesson. Never have highlights. They're just horrible. They're just bad, in my opinion. Um, That's not my opinion. It's actually a friend of mine that said, "Well, you probably should get rid of all the highlights because it's pretty bad." Oh, as you can see, a lot of things have changed. Yes, um, not that portion though. I think it's pretty good. I wish I think something changed there, but it's not really that bad. In my opinion, the highlight, sometimes I just leave the highlights there just because I made it into a text box, something like this, like this. Like, I'm not gonna change that 2.2 over here. That's what I thought. Until that probably is necessary. No, actually, that's not necessary. What you can do. So let me just pull that to one. Have a background that is white. So and then bold it by one. And then bold this by one. This just does help a little bit to actually prompt out that thing. I also like boxing in things. It makes it a lot cleaner, actually, in my personal opinion. And yes, this is a linear approximation, actually. I might do this later, although, honestly. It's gonna take forever to clean all of this up. I didn't even think about this. So, good thing to note. Yeah. As you can see from far away, it does look like those two lines do a good job approximating it, which is incredibly satisfying. Yeah. This is probably one of the few things I'll actually leave highlighted because they were ABC questions, and they're from the old me when I made questions that are pretty questionable at the best of cases. It's pretty questionable. Um, yeah, that does remind me human morality is pretty bad in my opinion, because no human's perfect. Yeah, actually, most of humanity is not perfect. As you can see, by the politicians, and in my opinion about the voting system, it needs to be rank based, right? I think rank based would solve a lot of the issues about the voting system. I also would want to get rid of this AI shenanigans, but you can't get rid of the AI, so you have to be careful about false information, which is very easy for the general public to believe. Very easy, actually. Very, very, very easy. It's not very that hard to brainwash a whole entire group of people. Not really that hard. One of my favorite things is this one because it actually just goes to magic numbers, which is incredibly satisfying in my opinion. Anyway, pretty good. I'm tired right now, which is why my voice is like we. I mean, it's not weird. I guess. Yeah, I changed this thing too. I love this change because it shows a little bit more of what the methodology is about shifting. Yeah. Anyway, I think that's all. Yeah. I think I showed off most of what I changed, so good on me, right? Yeah, I don't know if it's good on me actually, so I don't know.